The next topic in 2.1, the section on functions here, is function notation. And we're going to use the following notation throughout the semester to describe functions. All we'll do is we'll simply replace the variable y with f of x. Okay, and f is one of the letters we're going to use for function. There's going to be many others, like h of x is going to be a common one, for example, maybe k of x. You will see r of x, p of x, and c of x used quite often for revenue, profit, and cost. Anyway, so f of x, red f of x is denoted f parentheses x, and simply means the y coordinate of the function corresponding to the given x value. So in our previous equation that we were working with, y equals x squared minus 2, this can now be expressed as f of x equals x squared minus 2. And be careful, these parentheses do not indicate multiplication. There is no actual multiplication between f and x here. What this means is that x is the input for the function defined by the rule x squared minus 2. Let me say that one more time. X is the input for the function defined by the rule x squared minus 2. So here's an example. Consider our function f of x equals x squared minus 2. How do we evaluate f of negative 3? What does that even mean? F of negative 3. Well, think back to what we just said. X is the input for a function defined by the rule x squared minus 2. So f of negative 3 means that x equals to negative 3 is the input, and f of negative 3 is the corresponding output. Okay, and how can we figure out what the corresponding output is? All we have to do is evaluate the function's rule, x squared minus 2, when x is negative 3. So we write f of negative 3 equals negative 3 squared minus 2. Be careful, it's x squared, so you're squaring the negative sign as well, right? Because your x is negative 3 in this case. Okay, well that gives us 9 minus 2, or 7. So f of negative 3 really means what is the y value when the x value is negative 3, what is the output when the input is negative 3, and the answer is 7. We have a summary of this here on the next slide. Again, replace x with the value negative 3 and evaluate the function's rule. And what's going to happen is you're going to get the result of 7. This should be a negative. So this should be 7. Right? 9 minus 2, which is 7. This means that the point negative 3 comma 7 is on the graph of the function. Negative 3 comma 7 is on the graph of the function. So that's how you do function evaluation. Here are some other examples. What if our function was defined by this rule? F of x is the square root of 3x minus 2. Well, what happens then is if we were to evaluate f of 2, all we would have to do is replace the input variable x with 2. So everywhere we see x in our function rule, we write 2 instead. So here it's indicated in red. And f of 2 would be the square root of 3 times 2 minus 2. 3 times 2 is 6, and 6 minus 2 is 4, so we get square root of 4, or 2. And the input doesn't always have to be a number, right? It could be a variable, or for example, a here, right? And what happens then is everywhere we see our input, everywhere we see our input x, we replace it with the variable or letter if you want to go down that route, a. So this is going to be the square root of 3a minus 2, because that's what I obtain when I replace x with a. Likewise, our input could be an expression like 6 plus h that contains a number and a variable. Well, in that case, the output will be the square root of 3 times 6 plus h, the quantity, minus 2. And then we could work this out and simplify under the square root to get the final answer of 16 plus 3h. So this is how we evaluate functions here. Let's talk a little more about the domain of a function. We started this conversation in the previous video, so let's now apply it using function notation. Consider f of x equals square root of 3x minus 2. F of 0 would be equal to what? Well, f of 0 simply means find the output when the input x is equal to 0. We plug in 0 and we obtain square root of negative 2. But we know that this is not a real number. Square root of negative 2 is not a real number. So the question is, for what values of x is this function, f of x equals to 3x minus 2 in the square root, defined? For what values of x will I get an output, in other words? Okay, well, as you might imagine, this is defined only when the radicand, the thing or the expression under the square root is called the radicand, whenever that is equal to or greater than 0. Because only when you take the square root of an expression that's equal to or greater than 0 do you get a real number out as the output. Well, when is the expression 3x minus 2 greater than or equal to 0? That is when x is greater than or equal to 2/3, as is pointed out here. Right? So that's when I'm going to get an actual output here. That's the values of x that will give an output. Okay, so what do we say? We say that the domain of our function is the set of real numbers that are greater than or equal to 2/3. How can you write this out? There's several ways to do it. You could use interval notation, like we did in chapter 1, and you could say that the domain is the set of real numbers between 2/3 and, well, infinity. In this case, using a bracket because we have x bigger than or equal to 2/3. You could use the inequality that we just wrote out as well, or you could use set builder notation. That's what your book uses and calls it. And it's set builder notation. You use this curvy parentheses for set, and you say x such that x is bigger than or equal to 2/3. So here's how this is read. This is read, all the real numbers x, the vertical line is the bar here. It's called a bar, this vertical line. The vertical bar means such that. So this is all the real numbers x such that x is bigger than or equal to 2/3. Okay, and let's do an example together. Here's another one. Find the domain of the function square root of 1/2 x minus 4. So once again, what are you thinking? You're thinking we need to figure out for what inputs, for what values of x, will the radicand, 1/2 x minus 4, be positive or 0? Because that's when this function will be defined. Okay, so I need 1/2 x minus 4 to be bigger than or equal to 0. I'm going to quickly solve this inequality here. Multiply both sides by 2. And I get all the x's that are bigger than or equal to 8. All those numbers will give me an output. Well, let's practice one more time. So we have it as an inequality here. Let's write it in interval notation. It would look like this. And in set builder notation, it would look as such. All the real numbers x such that x is bigger than or equal to 8. Okay, so here's a summary of that answer. Just like that. And that's what we do when it comes to the domain of a function. Here's another example of domain. Find the domain of this rational function, f of x equals 1 over 3x minus 5. So what do we need to worry about again? What values of the input will produce an output? In other words, where am I going to have a problem here so that there is no output? Wherever there is a problematic value of x, I exclude it so that my function is still defined. Well, notice in this case, the function is defined for all values of x, except where the denominator of the fraction is 0. Right? We can't have a 0 denominator here. Well, this means all real numbers are okay except 5/3. Because if I plug in 5/3 for x, then I'm actually going to end up with 5 minus 5 or 0 in the denominator. And I can't have anything divided by 0. That's not defined in math. So that's why my domain is all real numbers x except 5/3.